Well, hello out there. It's Mrs. Coli. I hope you're having a great day. I know I always am when I get to study about math, and hopefully you like math too. My purpose today is to help you make fractions fun, and that you'll start to notice that fractions are everywhere. You just have to look for them. My objective today, or my goal for you boys and girls, is to teach you fourth grade math, fourth grade fractions, using what we've learned in first, second, and third grade, regular fractions, and now being able to multiply, divide, add, and subtract using the least common multiples and the greatest common factors. So we're going to take what we've learned and add on to that. So let's go back and review some of the important terms that we've learned as math students, as math scholars so far. The first word that we need to learn, it's an important academic vocabulary word specifically for math as we're talking about fractions, and that word is numerator. Can you say that with me? Numerator. Good. As you can see, it means the number of parts that we have. So a fraction is a part. It's a part of a whole. So as we talk about fractions, we need to visualize parts of a whole. And then you have the line, and then you have the number on the bottom called the denominator. Can you say that with me? Denominator. And that tells you the total parts in the whole. So far, so good? I hope so. Let's learn some more. As you've noticed from this lesson, it's all about fractions and how fractions are everywhere around us. So let's go back to first and second grade and review some of the things we learned back then. As you recall, your teacher taught you about proper fractions. A proper fraction is where the numerator is smaller than the denominator. These are examples of fractions I'm sure that your teacher taught you. Our examples would be, in everyday life, they're found in maybe a pie, maybe pumpkin pie that you ate during the holidays, or maybe in the pizza that you get from Papa John's or from Pizza Hut. They're usually sliced. A large pizza is usually sliced into eighths. And why is this important to you? Well, if you're really hungry, you would want to know how to get the most slices by using fractions. And there are secrets, and I'm going to share those with you in just a few minutes. Also, we can use things like fraction walls or fraction tiles to help us in knowing which is bigger and which is smaller, so that we can make good choices as we learn more about our fractions and how to get the biggest slice of the pie, so to speak. And the only problem with using these types of fractions would be we don't always have them with us. Our manipulatives are usually found in our classroom, and every day around us, we don't have access to those manipulatives. So we'll practice with them in class and get a better understanding of fractions, which we can apply every day in our life. So if I was to ask you, which is larger, 5/6 or 5/12, what would you say? Oh, okay. Well, let's see if you're right. The first thing I have to be aware of is that not all fractions have the same denominator. So I'm just going to ask you a quick question. Do you think you're going to get a larger piece if you choose the smaller denominator or the larger denominator? Let's think about that as we explore this using our fraction wall. 5/6. So I have to go to the denominator with the 6, and I'm going to count 6 or 5 of these parts. 1 part, 2 part, 3 parts, 4 parts, 5 parts. And so I'm comparing this length of this line from here to here. It stops there to 5/12. So I find the denominator with the 12 and I count over 1 part, 2 part, 3 parts, 4 parts, and 5 parts. So it would be right here. So I'm comparing this line to this line. And what do you notice? Do you notice that, to this line. Do you notice that 5/6 is quite a bit larger than 5/12? So what do we know about this? We notice that there's 5s on top. So when the numerator is the same, how do we know if it's larger? Did you just decide that if the denominator is smaller, it's a larger fraction? Wow, you are so smart. That's one of the important things to know about fractions. Let's discover some more. So now I know everybody who hasn't touched a ruler, who hasn't measured things with rulers. It's fun, isn't it? Did you know that using a ruler is using fractions on a number line? Did you know that? Well, it is. So this is actually what a 1-inch ruler would look like if we took and we extended the lines and looked at it as a fraction line, which would be 16 little lines on an inch ruler. And then you could measure things to here, or you could measure things to here and compare. So which is larger, 7/8 or a half? 7/8 or a half. If something was here, you would say 7/8 is larger than a half. So far, so good? I hope so. Well, let's learn some more. Okay, now we're going to review what is an improper fraction versus what is a mixed number. Do you remember? I hope so. Well, an improper fraction is an example of this number here, 7/4. It's improper because a proper fraction always has the smaller number on top and the larger number on the bottom. In this case, it's not proper, is it? It's improper. That im is a prefix that means not. So it's not proper because the 7 is larger than the 4. So we call this an improper fraction. This is a visual representation of 7/4. So as you can see, if I was to count out how many parts this would be, I would notice I had 1 pi, and then how many parts? I have 1, 2, 3, 4. So I put the 4 on the bottom, and I count how many of those parts are shaded, or how many did I eat? 1, 2, 3, and I put that number on top. These always represent the shaded parts, and the whole thing represents the total number of parts. So 7/4 is equal to 1 3/4. That's the correct way of saying it. So you can see that we need to know what improper fractions are, and we need to know what mixed numbers are, especially as fourth graders. And now we have to start multiplying numbers together and adding numbers together and subtracting fractions together. So we're going to take what we've learned with our regular multiplication facts and apply it to fractions now. One of the first things we're going to be aware of before we do that, before we start multiplying, I want us to go back and review one last thing. And this is a fun game that you can play with flashcards. It's called Fraction War, and it's helping you to really start to understand which is larger, which is smaller. Do you think 2/5 is greater than 2/6? Think about what I've taught you thus far. I said if you have the same numerator, so 2's on both, and we have a denominator of a 5 or a 6, which one did we find was actually larger? Did we decide that the denominator that is the smaller one, the smaller number, is the larger fraction, isn't it? That is a true statement. And you can see here, if you were to compare 2/5 to 2/6, because it has more parts, so each of the parts becomes smaller. So you can see that these 2/6 is going to be a smaller portion of brownies than this section of brownies with 2/5. So these are important things to be aware of. You can take a look at how each of these compares between the 4/5 and 4/6. And so what we're learning then is that when we have the same numerator on top, whenever you choose the smaller denominator, it makes for a larger fraction. These are important things to know as you're comparing fractions as a fourth grader. Let's learn some more. So before we move on to multiplying and dividing fractions, we need to talk, or even adding and subtracting fractions too. We need to review one last time, what are these fractions? What are they called? Do you know what you would call a fraction that is 1/5? Yeah, it's called a proper fraction because the numerator is smaller than the denominator. What do we call a fraction that looks like this? Did you say an improper fraction? I hope so. And you know that, and why is it? Well, because the numerator is larger than the denominator. And what did you call this? Well, it says a mixed fraction, but I call it a mixed number. Why is it called a mixed number? Well, if you look at it, it has a whole number 2, and then it has a proper fraction of a half. So far so good? You got it? Well, let's move on and study some more together. I told you that we would be multiplying fractions, didn't I? And there's things that we need to remember as we multiply fractions. If you're given a mixed number like this, There's a certain technique that you can use to get it from a mixed number to an improper fraction. Then you can multiply your improper fraction together. So as you can see, the rules say multiply first. So you would take 7, or 4 times 7 is what? 28. And then it says add on the numerator. So that's 29, and you leave the denominator the same. So that's what this is. 3 times 2 is 6, add 1 is 7/3, times by 4 times 2 is 8, plus 2 is 10 over 4. Now you're going to multiply across. What's 7 times 10 is 70. And multiply across. 3 times 4, you can see it right here, 3 times 4 is 12. Now we have an improper fraction. Now, what it says, they're glad if you can change them back to a mixed number. So to do it, you would just divide. You would divide 29 by 4, and you're going to get 7 with one remainder. And so you put the 7 in the front, for if I was doing this, and then I would put the 1 on top, and then what I divided it by in front of it. So this shows you an example of what 70 divided by 12 would look like. And you can double check that, because at this point you know how to divide 70 divided by 12 with remainders. And that will show you that you would have 5 remainder 10. Do it and find out, though. It's always fun to practice. So now we're going to make our improper fractions glad. Okay, another thing to be aware of with fractions is, what if we're given 2/4 of 16? How could you represent that? I know it's really good to represent fractions as numbers. And so you would take your 16 parts, and you could use counters if you want to represent it. You would divide it. It says divide it into 4. So you divide it into 4 groups of a fourth first. And so let's first talk about what would be a fourth of 16. Well, a fourth would be 4, right? But this is 2/4, so I have to add this plus this would give me 8. So that's one way of representing what 2/4 of 16 is, using counters. Here's a different way, using like the area model. So they're saying, okay, what's a fourth of 40? So they put the 40 on top, and the 4 represents how many parts? So I have 1 part, 2 part, 3 parts, 4. So really you're just going to take 40 divided by 4. So each of those is 10. So 40 divided by 4 is 10. So a fourth of 40 is 10. I'm just showing you this quickly. These are things that your teacher will go over with you. A third of 27. Well, really all you're doing is taking 27 divided by 3. You can represent it here if you'd like, the 3 parts of 27. So what is this going to equal? Well, we know that 27 divided by 3 is what? Did you say 9? Nice job. So really, this is not that complicated. It's just using all of the skills that we've learned thus far. So if we know that a third of 27 is 9, you can represent it. It's always good to draw what we're thinking and prove to those around us that we understand our answers that we're getting. Checking our work is always a good thing as a math student. So I drew out 27 diamonds, and if I have three groups of them, I know that we decided a third of 27 was 9, because we did 27 divided by 3 is 9. Well, what about 2/3? Well, I'm going to have to take and add these together. So what's 9 plus 9? Did you say 18? So what would be 2/3 of 27? Did you say 18? You got this. Nice job. So how would I read this to someone? 3/5 times 25 equals 15. Well, when you see it as a fraction, you're going to add the word thus on the end. So it's 3/5. And really the multiplication sign means of. So you would read it as 3/5 of 25 equals what? And the answer is 15. You're getting so good at your fractions. Way to go. So can you explain how to solve this type of problem using the visuals that I've given you? Go ahead and stop this video and talk to a partner and see if you together could figure out how to solve this using this representation with my fractions. How'd you do? Does it make sense? Did you draw out the 10 parts? The number on the bottom tells you how many parts. So you should have drawn out 10 parts. And and it has to equal 80, so you'd put the 80 on top. And then what would you do? We decided that we would take 80 divided by 10 equals 8. So each of these parts here that you're solving for would equal 8, right? Then what would you do? Did we decide that because 7's on top, we have to times it by to find out how much this value is? Because we know that all of this is 80, so how would we find out what this value is of that number? 7/10. Because we're not finding it for 1/10. We're not solving it for just this, right? We're solving it for all of this. So did you say just take the answer, 8, and times it by those 7 parts? And that would give you 56? Awesome. You've got this. So if you're still confused, I thought I would go ahead and show you the solution for how to find fractions of whole numbers. So this represents 4/5 of 40 equals 30. And this shows you step by step what I just showed you with your visuals using the area model or the representation of the fractions. I hope that this is making sense. If not, just know your teacher will be going over this with you in greater detail. Okay, let's review some important vocabulary words that we've learned. We've learned what factors are, numbers that are multiplied together to form a product. So the factor pairs of 8 would be 1 times 8 or 2 times 4. Does that ring a bell? You got it? Okay. Because you need to know what a factor is for what we're going to learn about next. Also, we need to know what multiples are. Do you remember what those are? Those are the products of a number multiplied by any other whole number. The first 4 multiples of 8 would be, so it's really skip counting by 8, isn't it? 8, or 8 times 2 is 16, or you say what's 16 plus 8, or 8 times 3 would be 24. What's 8 times 4 is 32. And again, if you still haven't learned your multiplication facts, just use repeated addition or skip counting by 8 would work too. But you're going to need to know how to do this as you compare your fractions and as you simplify your fractions. These important terms come into play. So now we're going to be learning what our objective was today. I told you that we'd be learning what is an LCM and a GCF. Well, an LCM really stands for least common multiple versus the GCF, which is the greatest common factor. Okay, so this is going to show you what you would do for each of these and how they're different. I'm going to now go into detail and talk to you specifically about each one so that you can use that to help you as you're finding your greatest common denominator, as you're finding a common denominator, or as you're simplifying your fraction. So let's start with the LCM, which is the least common multiple. Why would you want to learn how to do this? It's always good to tell yourself, why do I want to learn this? Because maybe right now you're feeling complicated. It's feeling overwhelming and you're feeling complicated. It's feeling complicated with all of this that you're trying to learn. So let me tell you why. Because if you can find the least common multiple, it's going to help you find the common denominator, which allows you to add and subtract to compare your fractions, or to even add and subtract fractions. Okay, so what was the least common multiple again? The smallest positive number that is a multiple of 2 or more numbers is called the least common multiple. For example, the least common multiple of 4 and 12 is 12. So we're comparing 2 things together. So what would be the least common multiple between 4 and 12? So all you're going to do, because it says a multiple again is, remember where we do the multiples of 4. What are the multiples of 4? 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Or you just say, what's 12 plus 4? 16. What's 16 plus 4 is 20, and skip counting by 4. But these are called multiples. What are the multiples of 12? So now we're using our multiplication facts of 12. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. Remember that? Those are multiples, aren't they? So what you're going to do is you're going to find the least common multiple of these. Okay, so of 4, we have all the way up to here. What is the least one? Do you notice that they're both 12? That's the smallest one you could choose. So this is showing another example of what if you're given a fraction like this. You can't add these together. You can't solve this problem if you have 2 different denominators, just like we couldn't solve this without using tiles to figure out, or a number line to figure out which one was not, smaller or larger. So this is when you want to use your common denominator. So you find something that's similar between the two of them. So this is what you would do. Use your least common multiple. So you could make a table like this, and you could compare the two side by side and start with 9. 9 times 1 is 9, or you would say 12 times 1 is 12. And then you would go 9 times 2 is 18, or 12 times 2 is 24. We haven't found anything that's common between them. That means the same. So we keep going until we find something. So we'd say, what's 9 times 3 is 27. What's 12 times 3 is 36. Then I do 9 times 4 is what? 36. Do you notice that we just found that they have something in common? So if I wanted to add this fraction together, these fractions together, I would have to do a conversion of taking the 9 and making it have a denominator of 36. And I'll show you in a few minutes how you would do this. Okay, so don't get confused. It's all going to make sense. Okay, now I'm going to stop for a minute. I'm going to show you how to find what the GCF is, or the greatest common factor, and how you can use this to simplify your fractions. This will make your life so much easier. But we have to first figure out, well, how can we compare these numbers and find the greatest common factor between them? So what you need to do is you need to take each of the numbers and you need to find its factors, just like it said, factors, greatest common factor. So you would say 1 times 36 is 36, 2 times 18 is 36, 3 times 12 is 36, 4 times 9 is 36, and 6 times 6 is 36. These are all of the factors that coordinate with 36, that make the product 36. Then I'm going to look at all of the factors that make up the product 42. Product means answer. So I would start with 1 times 42, 2 times 22, 3 times 14, and 6 times 7 equals 42. So I look at these and we want to find the greatest one that's in common. I notice it has the 1s, but that's not the greatest or the largest. They also have 2s, but that's not the greatest. They also have 3s, but that's not the greatest. This one has a 4, this one doesn't, but I notice they both have 6s, and it's the greatest number out of those. So I would choose 6. And I would use that to simplify a fraction if I had maybe 36 42s. And I needed to simplify that to a smaller number. I would use this to simplify that. So let's go ahead and look at this problem here and use it to simplify this fraction. So let's say I had a fraction of 2036. I've already showed you what I would do, but let's pretend you don't see the answer here, and let's try to work this through. So what I would do is I would take the number on top and write it here, the number on the bottom and write it here. And then I would do like my rainbow factoring. And that's where you just take 1 times 20 is 20. 2 times 10 is 20, or 4 times 5 is 20. And I do the same thing, rainbow factoring for 36. 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. And 6 times 6 is 36. Then I have to find the greatest common factor. I notice they both have 1s, but that's not the greatest. They both have 2s. That's not the greatest. I notice they both have 4, and there's nothing else that is in common. So I just found my solution. It's a 4. So then I would have to divide these numbers by 4, and that would help me to reduce it and to simplify this fraction. So what's 20 divided by 5 is 5. What's 36 divided by 4 is 9. So now I've reduced 2036 to 5 9s. This is a very important skill that you're going to need to know as you're asked to simplify large size fractions. You need to remember to always go to your greatest common factors to help answer this. So if I gave you 16 and 24, would you be able to come up with 8 as the greatest common factor? I hope you can. Practice this and see if this makes sense to you too. Okay, last but not least, we're going to practice using The least common multiple to help us find our common denominator. I told you we'd be coming back to this in just a minute, but before we do that, we need to make sure we all understand what is a common denominator. That's when two or more fractions have the same denominator. So a third, 2/3, or 3/3. We say that they all have common denominators. They share a common denominator. So the common denominators of these three fractions would be 3. So in order to add or subtract fractions, we have to have a common denominator. So I'm going to show you here, if you were given 3/4 plus 2/3, what would you do? I notice they have different denominators. Well, this is when, I want you to think about that for a minute. What would you do to figure this out? Because I've shown you the steps of what you do once you figure out, but let's talk about how would you take this and figure out what your common denominator is. If you remember from before, I'm going to go ahead and make a text box right here. Okay, before we learned that we're going to have least common multiples is where we have to do the multiples of these things. So I'm going to put 4 first because it's listed first. I'm going to stretch this out too. I'm going to show you what you can do. Maybe you would know too. Remember, if we're talking about least common multiples, help us find a common denominator, we have to take the numbers on the bottom and find its multiples. Okay, so I put 4 like this, and I just go through and say, what's 4 times 1 is 4. What's 4 times 2 is 8. What's 8 times 3? I'm sorry, what's 4 times 3 is 12. What's 4 times 4 is 16. So you're just going to do this for both of them and find the least common multiple is what you want for your common denominator. What's 4 times 5 is 20. So let's stop there because, again, we want the least. We don't want a big number. Okay, so now I'm going to do the same thing for 3, which is right here. Okay, so I'm going to put 3 equals what? 3 times 1 is 3. What's 3 times 2 is 6. What's 3 times 3 is 9. What's 3 times 4 is 12. Oh my goodness, what do we notice here? Did we find it? Did we find our common denominator? Yes, we did, because we found our least common multiple. I see a 12 and a 12. Okay, so we're now going to take and we're going to try to convert 3/4 into a number that has a 12 on the bottom and 2/3 into a number that has a 12 on the bottom. So what you're going to need to do is you're going to have to take your 3/4 and times it by 4 times what is 12? It's 3. So 3/3 is the same thing as one whole number. And in 3rd grade, I know I taught that. And so 3/3 is like having 3 parts and you ate all 3 parts. You ate the whole pie. So this is a way that you can make your conversions without affecting the value of those fractions. So what's 3 times 3 is 9. 4 times 3 is 12. And we would do the same thing now with the 2/3. We need to come up with a common denominator of 12. So I take and write my 2/3. But did you notice I made a mistake? What works for this one? Is that going to work for that one? No, because 3 times 3 was 9. So there's a mistake here. So you need to be aware of your mistakes. So this is not going to be the answer that you're going to want. You don't do the same thing on both sides. Don't let that fool you. You're going to have to say 3 times what is 12? And the answer is 4. So this one's going to be 4/4. Okay, so these are going to be different because those are the factors that you multiplied together to get 12 as your product. So 2 times 4 is 8 and 3 times 4 is 12. Now you can go ahead and add what's 9 plus 8 is 17. And your denominator stays the same. So when you're adding fractions, you only add the number on top. The denominator stays the same. So is this a proper fraction, improper fraction, or a mixed number? The way it's written right there. And the answer is improper. So I'd want to fix it, wouldn't I? I want to make it glad. And I want to get it to a mixed number. I want to get it to a mixed number, which has value to me. And I understand it better than 17/12, because right now it's It's improper. I want to get it to where it's a mixed number with a whole number and a proper fraction. Well, as you can see, that's the end of our lesson on fractions are fun and knowing how to use the least common multiple and the greatest common factor to help you in solving your common denominator so you can add and subtract fractions, and also knowing how to use your greatest common factor to simplify your fractions. I hope this lesson helps you today. I know it's always good for me to go back and review the importance of fractions because they're everywhere. Well, until next time, boys and girls, remember to make it a great day. And fractions are fun. Until next time, bye-bye.